Hi everyone. So today we are gonna solve a array problem which will teach us how do you find maximum difference between increasing elements. The problem is given a list of integers, find the maximum difference between two elements where the smaller one appears before the larger one. If no such pair exists, return 1. This is just a short explanation of the LeetCode problem. So for more clear explanation, we'll just go through the question here, which is given a zero indexed array nums of size n, you have to find the maximum difference between nums of I and nums of j. The difference is how you find is nums of j minus nums of I, and you should be careful about how you find the difference. You should verify this condition mentioned in the problem. It should be satisfying this. So nums of I should be less than nums of j. Return the maximum difference. If no such I and j exists, return -1. So let's take an example to understand this better. Suppose the input list given is the first example here, 7154. We want to find two numbers such that the smaller number comes before the bigger one, and the difference between them is as large as possible. Here, 1 comes before 5. So, 5 minus 1 is 4, which is the maximum difference, C. So, 7 and 1. Nums of I, which is 7. Nums of j, which is 1. So, when you subtract j minus I, which is 1 minus 7, it is minus 6. It's not a larger difference in the array if you see. Whereas, when it comes to 1 and 5, when you subtract 5 minus 1, it is 4. So, this is the maximum difference. So similarly, if you see the second example, there are no such pairs which satisfy the condition. So according to the question, if no such I and j exist, you have to return -1. When it comes to example 3, 1 and 10. When you subtract 10 minus 1, it is 9. So it is the maximum difference for that example. And now when you see this code which I have solved, this is a brute force approach. So a brute force way would be to compare each number with every number after it and check if it's smaller, then compute the difference. But this takes O of n squared time. N square is because we have two loops, one for the I loop and one for the j loop. So if you decode this code here, for I in range of len of nums minus 1. So according to the example, it will first start from 7. And the next loop for j in range of I plus 1 and len of nums. So let's say if I is starting from 0, from the code I have typed, j is starting from I plus 1, which is 0 plus 1. So it will be starting from the first index. So 0, I will be 7 and j will be 1. So this is a continuous loop. You will have to check each and every number so that it will take O of n square time complexity. So optimize this approach, I have did another code. I've found a way to do it. Before that, I'll just explain you what I did in the code. So this li is a variable assigned to a list. Okay, for I in range of len of nums minus 1, for j in range of I plus 1. I have told you, I have explained this. If I is starting from 0, j will be starting from the next index of the I. Now, if I is less than j, I will compute the difference and store it in a value. After storing the value, in the end, your motto is to return the maximum difference. So how will you know what number you should be returning in the end? So to do that, I've stored this computed value in a list so that in the end, I'll return the maximum of the list if you have the difference, or if there are no such existing pairs, you will return -1. So this is our brute force way of approach. How do you solve this problem? Now let's do a optimized version of this. I'll explain you that as well. Now, how can you optimize this? What I'll do is I'll take a variable mini, let's say. Initially, it will be so it will be nums of 0. Now the difference you have to calculate. I'll put maximum diff is what I have to return in the end. So maximum diff, if there are no such existing pairs, it will be -1. So I'll give -1. And now list. Because mini is starting from nums of 0, I will start the array traversal from the first index. So for num n nums of this, right? If num is greater than min mini. Now what I'm doing is I have to check this condition, right? Nums of I and nums of j. So for that I'll do if I'm checking if j is greater than I or not. So if it is the case, what I can do is max diff is equal to max of max diff with num minus mini value, right? And now if not that is not the case, we can change the mini value. So like here, if if it is not satisfying the case, that means the number is not greater, right? So we will go mini to the mini variable to update, and we'll change the num to the num, right? So if this is the case, we will return max diff. I hope it works. Yes, we have passed all our test cases here. Let's see. 3 test cases have passed, but we have to check for all the test cases here. Yes, 4 millisecond. If it was brute force, if it was brute force, I don't know how long will it take. Let's go check again, right? Solution. So this is my brute force approach. I'll just try to copy it here and check how much time will it take. It is taking 113 millisecond, 109 millisecond. So here itself you can understand how long the runtime is. So it should be optimized this way. So these are both my ways of both brute force and optimized way. This is how I solve a problem, understand it, break down, and understand it more clearly. The only thing I follow from a person who suggested me is what I always think about. Keep the coding part aside. How do you understand a problem? If in real time, like let's say someone gave you this pen and paper to solve and tell them the maximum difference, how do you do? Like you will just go through each number and solve it, right? That's what I did before, but then I try to find an optimized version of it, and this is it. So any suggestions, please comment down below, and I'm free to take any suggestion you give me regarding this problem or any problems which are existing in the channel. I know I am new here, but I would love suggestions to take from you. Yes, please. So thank you for watching.